Hi everyone, this is Mrs. Eggerding and you are watching Unit 7 Video 5 and we're going to hit the last of our graphs for this unit, graphs of logarithmic equations. Now in class we introduced to you the idea of a logarithmic function and we just want to expand on that on this video. First we're going to compare it by inverses to exponential graphs. We know exponential graphs have a domain of all real numbers, the basic ones at least, a range from 0 to infinity, not including 0, because y equals 0 is a horizontal asymptote, and we have y-intercepts at 0, 1. Now because logarithms and exponentials are inverses, I can swap all this information to get a description of logarithmic graphs. So the domain of a logarithmic graph comes from the range of an exponential graph. So my domain is going to be 0 to infinity. My range of a logarithm comes from the domain of an exponential graph, and it will be all real numbers. The asymptote, well, the asymptote is no longer a horizontal asymptote. Range is all real numbers. But it is now a vertical asymptote at x equals 0. And in a logarithmic graph, I no longer have a y-intercept, but its inverse is the x-intercept, and instead of being at 0, 1, it is at 1, 0. And so I can use all of the inverse information to get an idea of what a logarithmic graph looks like. And so here's our picture, domain, 0 to infinity, range is all real numbers. It is a vertical asymptote at x equals 0, and it's at an x-intercept of 0, 1. The interesting thing about all this information, it is independent of this a. This base value of a does not matter for this information. So if I take a look at a basic logarithmic here, log base 2 of x plus 3, I can get a sketch by talking about the transformations. So the plus 3 is going to take my logarithmic graph and move it up 3. Now moving it up 3 does not change my domain. It is still 0 to infinity. Up 3 does not change my range. My vertical asymptote has not moved, but my x-intercept has. So let me sketch what we have so far. Here's our vertical asymptote. Okay, and let's think about what happened. On a basic logarithmic graph, my x-intercept would be at 1, 0. But this has been moved up 1, 2, 3. And so my x-intercept has gotten moved up. So the question is, where is my new x-intercept? Well, x-intercepts tell me that the y is 0. So if I set this equation to 0 and I attempt to solve, I have negative 3 equals log base 2 of x. Right now, the only way we know how to evaluate this is to change this to an exponent. And so the exponent version becomes 2 to the negative 3 power, which happens to be 1 over 8. And so my x-intercept is 1 over 8, comma, 0. Really close to that that y-axis. And so my graph will do something like that. We are going to talk about how we can get more exact ordered pairs, but we need to have a few more understandings about logarithmic of functions before we can get that. So we're just going to focus on these things: the domain, range, asymptote, the x-intercept, which will rely on us changing things to an exponent, and then getting this basic shape. Your transformations should help you get that. Okay, well, let's take a look at this one. Log base 2 of x plus 3. The quantity x plus 3 means this plus 3 is now a shift left 3. A shift left 3 is going to move my asymptote. Instead of being at 0, it will now be at negative 3, which shifts my domain to be negative 3 to infinity. My range doesn't change. It's still all real numbers. And let's talk about that x-intercept. That x-intercept was at 1, 0, but now I will move it left 3. 1, 2, 3. It is still an x-intercept, and so it's at negative 2, 0. Again, we're going to worry about getting some other points later, but we can go ahead and sketch a basic logarithmic graph that looks like that. Your assignment on page 428, numbers 33 through 38 all, they ask you to use the transformations very similar with what we just did on here. There is an entrance slip with this quiz, entrance slip 5. Go ahead and complete that. What we hope you can do is, given these logarithmic equations, be able to state domain, range, x-intercept, and the vertical asymptote. Bring your questions to class, and we will talk to you later. Thanks.